Hello everyone. Welcome to the static part revision or quick revision for the CSP 2025 sessions, right? So today we will discuss about the isotherms, and there is a recent question also from 2024 UPSC Civil Services Prelims, right? So this is one of the critical topics for the students from geography. It's very highly conceptual in nature. So we'll try to make up it a very simple thing with examples so that you understand it clearly, right? Yeah, so isotherms, what actually these are? So this is the basic definition. Isotherms are the lines which joins the equal temperature points, right? So across globe, we have a different temperatures, whether it is in oceans, whether it is in continents, whether within continents, within oceans, we have a different temperatures influenced by latitudes, altitudes, and many other things like ocean currents, winds as well, right? So basically, isotherm means lines joining equal temperature points. Fine. So to understand this isotherms distribution, we can take two seasons, that is January and July, where extreme temperatures are recorded. For example, if you take January, we have in the northern hemisphere, we have a colder seasons, whereas in southern hemisphere, it is a warmer season, that is summer, right? Similarly, in July, northern hemisphere has the summer season and the southern hemisphere has the colder region, right? So these two seasons are the benchmarks to evaluate the isotherms across the globe. So let's take the distribution month of January, right? So isotherm means lines joining equal temperature, we have just seen. So if you take this isotherm, and this is the latitude, right? So you all know that latitudes, which is starting from equator 1, 2, 3 degrees until 90 degrees, right? So this 10-degree latitude, isotherm, you can see here. So the temperature at in this particular point where the line is there, here there is a 10-degree temperature, and this 10-degree temperature is at this latitude. So you can see, you can superimpose here the temperature in the oceans is 10 degrees is at in the higher latitude, right? So the same 10-degree temperature on the land is at lower latitudes, let's say 10-degree latitude, and here it is more than that. It can be 15 degrees, 16-degree latitude. So basically what I want to say is here, the temperature or the temperature at the land during the January is at the lower temperature, whatever it is recording at the lower, not lower temperature, lower latitude, whatever the temperature it is recording, the same 10 degree, the same temperature on this particular latitude will be different in the ocean, that is in the reporting in the higher latitude. So no need to confuse. We'll come back to this point again just to make you know the context, right? That isotherms are not parallel or straight in the oceans and land. It actually changes, right? We will discuss this, but before this, we need to understand one point, a very important point, that is the land heat or cools much faster than oceans. Why? There is a reason. For the specific heat of water is much higher than land. It means oceans or water requires more energy to take the temperature, whatever may be. Either it is cold or either it is hot. It will take some time because it has a high specific heat capacity. Whereas land has low specific capacity, heat capacity, where it can take the heat or cold much faster, right? So this is a very basic condition that you need to understand, that land takes the cold or hotness much faster than oceans, right? Now coming to the month of January, you can see here in the northern hemisphere, we have winter, right? That means it is a colder ones, right? So it is a cold temperatures that is being recorded in the northern hemisphere. Let's take, as there is a colder temperature, land will take much faster. The coldness will be taken by land much faster compared to the oceans, right? For example, on the land in this latitude, for example, usually the latitude mimics the temperature, right? So if you take this latitude, say 7 degree or 8 degree, whatever the latitude, if you see the 10 degrees, that means it has taken, the land has taken the coldest much faster when compared to the ocean. So if there is a 10 degree on this latitude on land, the same temperature of 10 degree, if you take superimpose in the ocean, it won't take the cold much faster. It takes much slower. The ocean or water takes the cold much slower. So it means in the same latitude where land is recording 10 degree, on the ocean, it actually is a less than that, right? So it takes cold very, slowly. That means whatever the 10 degrees that is there in the land, the temperature here on the ocean, the same latitude is higher, like 15 degree, 20 degree, or 17 degree, 18 degree. So if you want to see the coldness of the same, that is 10 degree temperature, you have to go to higher latitudes in the ocean because it is taking cold very slowly, right? So land has taken 10 degree, coldness much faster. So you can see in the lower latitudes, it was recorded. The same 10-degree temperature will be recorded in the higher latitudes because as you move towards the higher latitudes, temperature decreases. So on the same latitude, if you see here, if you superimpose, if you measure the temperature here, it will be much higher than 10 degrees, like 13 degree, 14 degree, 15 degree. If you want to see the same 10-degree temperature on this ocean, you have to reach to the higher latitudes, right? So this is the isothermal line where the isothermal lines are deviating towards the north to the higher latitudes in the oceans, right? And southern side in the land because land is taking much cold earlier. In the lower latitude itself, it is taking more cold, whereas ocean is not taking that coldness as fast as the land is taken. So it takes some higher latitudes to measure this temperature of 10 degree, right? So this is the month of January. Now let's take the example of the month of July as well, right? In case of July, the northern hemisphere experiences summer, so the temperatures are much higher, right? Now, if you take the same land, the case of land and the oceans here, the land takes much temperature much faster than ocean. So if you take the 10-degree latitude, say 10-degree latitude, and the temperature on the land, say for example, on the ocean, you can take 20 degree. So it has taken that 20-degree temperature on that particular latitude. But if you move to the same latitude in the, land mass, the temperature here won't be the same. It is actually taking much higher, faster heat, right? So if you want to see this 20-degree temperature, you need to move to the higher latitudes. Why? In higher latitudes, the temperature gets decreased, right? As you move towards the higher latitude. So this 20-degree temperature, you have to go to higher latitudes. So if you superimpose here usually it will be 30 degree, 35 degree in the land because it is taking much faster. The heat is being taken by the land much faster, where ocean has taken slowly and it recorded 20 degree. And if you go to the same latitude on the land, it will be 30 degree. So if you want to see the 20 degree, what you have to do? You have to move towards the higher latitudes where temperature gets reduced with the higher latitudes, right? So here the deviation in the landmass is northern, whereas in case of January, the deviation of isotherms is northern in the oceans, southern in the land. But in case of July, as it was reverse summer season, the tilt of the isotherms is northern on the land and the southern in the oceans, right? So this is how the isotherms are measured. You can practice for the southern hemisphere, right? And if you have any doubts, you can put in the comment section so that I can answer as well. So try after listening and understanding this northern hemisphere, try to solve for the southern hemisphere in both January and July, and then try to understand it. And if you have any doubts, you can put it in the comment section, right? Now let's see one question asked in the 2024 UPSC Civil Service Prelims this year itself, right? Which of the following is correct? Interference or inference from isothermal maps in the month of January. So in the month of January, northern hemisphere experience the winter and southern hemisphere experience the summer. Anyway, that is not matter here. Let's see. Isotherms deviate to the north over the ocean and the south over the continent. This is correct. Why? In the January, we have a winter season. So land takes much colder temperature. If you take 10-degree latitude, let's say temperature is 5 degree in the land. The same on the 10-degree latitude, if you go to the oceans, the temperature will be higher because ocean won't take the coldness much faster. So it can be 10 degree, 12 degree. So if you want to see the same 5-degree temperature, you need to move towards the higher latitudes. So isotherm moves towards the north in the ocean, south in the continent. So this statement is correct. And the presence of cold ocean currents, Gulf Stream, North Atlantic drift makes the North Atlantic Ocean colder and isotherms bend towards the north. No, because this Gulf Stream, North Atlantic drift are actually the warm currents, right? So it influences the higher temperature. So here the statement itself is wrong. So answer is 1 only. Fine. So this is about isotherms and its concept. It is a very critical one to understand. So try to understand it. If you have any doubts, please do comment, right? So that's all. Thank you.